Hello, everybody. All right, so today I'm going to try to make this brief, but we're going to talk about signal flow and audio recording. If you're going to do any kind of audio recording, then you need to understand signal flow. So what signal flow is the flow from where a signal starts and where it ends. And we need to make sure that our signal ends up where we want it. And that's going to be in a few different places, actually. So what's happening in signal flow is we want to record an analog sound, so a sound from the real physical world, and we want to capture that on a digital platform like a computer inside of a software like Ableton. And then we want to be able to hear that back from our speakers and in our headphones. So there's a little bit that goes into this. So the first thing that we'll talk about are the different kinds of microphones that we can capture audio with. We have condenser microphones, so this is one form of a condenser microphone. This is called a shotgun mic. It's incredibly directional. It's got this long snoot on it, basically, so you can really reach far with it. And we've got this is kind of a large diaphragm, so it's got the large diaphragm here to capture the audio. And this is also a condenser microphone. And then we have dynamic microphones. There are different styles of microphones besides condenser microphones and dynamic microphones, but these are the two most common types of microphones you're going to see in the real world, so we'll just focus on these two. So we have dynamic microphones and we have condenser microphones. And the difference between the two is that condenser microphones require a small amount of power in order for them to become active. They have to have what's called phantom power, plus 48 volts of phantom power. Then the condenser microphone, when it's powered, becomes incredibly sensitive to nuances, to the smallest of sounds. And this is why condenser microphones are mostly used in studio environments, for the most part. Or let's say they're not used for live performance because they're way too sensitive. What would happen is if I use this microphone and I'm the singer in a band and I go on a live performance tour, or let's say I perform on stage, this microphone is going to pick up everything in that room, all the drums, the guitars, the crowd. It would become a total mess. And so you really want to be in a controlled environment when you're using condenser microphones, because they're really very sensitive microphones. For live performance situations, you're more likely to use a dynamic microphone. Dynamic microphones do not require phantom power, so they don't need a preamp to supply the phantom power. So phantom power is provided by preamps, and we'll get to that here in just a second. So dynamic microphones do not need preamps. They don't need phantom power, so this is why they're much better for using in live situations, because they're much more robust. They take a lot of sound to be responsive to sound. So you'd have to be very close to the mic. You'd almost have to be right up on it in order for this microphone to be very responsive to it. So it's not going to pick up all the nuances. It's not going to become charged with a little bit of electricity to become incredibly sensitive. So it's not going to pick up the drum kit behind me or the crowd. It's really just going to pick up like almost literally what it's touching. So this is why people use dynamic microphones for live situations, is so that they're not getting what they call bleed from other instruments into the mic that it's really dedicated for. So this microphone here is called the Shure SM57. It's a really, really popular mic. They're about $100, and they're used all the time. And you can use dynamic microphones in the studio, so don't think that you can't. It's just that they don't need phantom power, and usually you would be recording something a little more robust in the studio, say like a guitar amp or something that's really loud and crunchy and heavy. You probably wouldn't want to use a condenser mic on that. You'd probably want to use something like a dynamic microphone. If you're unsure whether a microphone is a dynamic mic or a condenser mic, just Google it. Type it into Google, into your phone or whatever, and just look at the specs on it, and it will tell you whether or not you're working with a dynamic microphone or a condenser microphone. And the more experience that you have, you're just going to be able to start to tell these things really quickly. And in fact, this microphone right on it says dynamic. So I know this is a dynamic microphone. So dynamic microphones do not require phantom power. Therefore, they do not require a preamp. Condenser microphones need phantom power. Therefore, they require a preamp. So we'll talk about the next thing in the chain here, which is going to be our XLR cable. So we have sound coming out of my mouth. Now we have a microphone to pick that up. Now we need to get it into the preamp that's on the audio interface. So here's our XLR cable. You'll often hear of these cables being referred to as microphone cables also. So this is both ends of it at the same time. We have one end that has 3 prongs in it, and this is the male end. And then we have the opposite end of that, which is the female end, and this is the side that goes into the microphone. And the female end will always have this release clip on it. The male end won't have a release clip on it. So the female end goes into the microphone. So on our microphones, they'll all have the 3 prongs there. And basically we just line that up with the 3 holes on the XLR cable, the female end, there you go, you can see it there. And we just plug that into the mic. We plug it in and we want to hear it click. There we go. Sorry, I only have one hand here. We want to hear that release button click into the microphone so that we know it's fully connected. So now we've got our XLR cable, and we need to plug the other end of that into our interface, our audio interface. And I have one here. This is an old one. So audio interfaces come in all kinds of shapes and sizes. There are thousands and thousands and thousands of different models of audio interfaces. This one happens to be kind of old. This was made by M Audio, and essentially I have another one here that I use in my studio, but I can't show you. It's all hooked up right now, so I'll do a little. Maybe send you a link to the one I'm using now. But anyhow, the idea is that the audio signal then comes into the audio interface, and this audio interface has a lot of different inputs. And some of them are XLR inputs. In fact, only 2 of them are XLR inputs. And all of the rest of them are what's considered to be a line input. And we'll talk about line inputs after we get through this. All right, so if you have XLR inputs, then it's likely that you're going to have preamps in this audio interface that will send phantom power to the microphones. So this audio interface in particular has 2 preamps. It has 2 places where I can plug in an XLR cable. And what I can do is I can press this little button, and that turns the phantom power on for this channel. So now this microphone is supplied with phantom power. So phantom power is an optional switch. So for instance, I could plug the dynamic microphone into this input, and as long as I leave that phantom power button off, then the microphone will work normally. If I plug in a condenser microphone, I need to turn that phantom power on for the microphone to be responsive to any sound. So inside of this interface here, there's 2 little amplifiers that send that power to the microphone. They're called preamps. So the audio interface that we have at the university, which I'll show you later on, has 8 inputs. It can record up to 8 instruments at one time. Up to 8 audio inputs. How about that? 8 audio inputs at one time. 4 of them can provide phantom power. So inputs 1, 2, 3, and 4 can provide phantom power again, it's optional, but those are the 4 that can provide phantom power. 5, 6, 7, and 8 cannot provide phantom power, so they would be more of a line input, say for like a guitar, or a dynamic microphone that doesn't need the phantom power. So I doubt we'll ever get into a situation at the university where we need more than 8 inputs at one time, and I'm pretty doubtful that we'd ever get to the position where we would need 4 powered inputs at the same time, but we have the option there. So for the most part, if we're just recording one thing, we're just going to need to use one input. So we'll just stick to using input 1 at the university, and then we'll go to input 2 if we need to add a second input that we need to record simultaneously. Otherwise, we can just record on input 1 every time we need to record. Alright, so now what happens is, now that we've provided phantom power to the microphone, when I sing in it, the signal is going to come. First of all, there's power being provided to the mic, and then I sing in it. The signal comes into the preamp or into the audio interface. It gets converted from an analog signal into a digital signal. So audio interfaces, this is why they're important, because you can buy preamps that are external that have no technology as far as getting the information into the computer. And that's why the audio interface is so important, because it converts the analog signal into a digital signal. So it's called an A to D converter, analog to digital converter. Once that analog audio gets converted into a digital language, it then leaves through a cable that you plug into the back of it. Usually they're Thunderbolt or USB these days, and it goes into the computer. So that signal is coming in from an analog source. My voice goes through the microphone, goes through the cable, goes into the audio interface, gets converted from analog into digital, leaves the audio interface and goes into the computer. And then at that point, that's where we decide what we want to do with it when it gets to the computer. So what we want to do with it is we want to open up Ableton Live, and we want to direct Ableton Live in our preferences, in the audio preferences, to use our audio interface as our input and output device. So this is why we're going to go into the preferences and make sure that our input and our output device is the audio interface. And at the university, what you're going to see come up in that drop-down list as the audio interface is the Thunderbolt Apollo 8, or Universal Audio Apollo 8. So, and I'll send you some information on this audio interface so you can get more familiar with it, but that's the audio interface we have at the university. It's a really nice audio interface. So you'll select that audio interface as your input and output device, and now what happens is Ableton becomes responsive to the inputs on this device. So it will know this has 2 inputs that in the university, it'll know there are 8 inputs that you can choose from on all of your audio Ableton tracks. So if I open up Ableton and I go to any of my audio tracks and I select an input for it, I'll have the option to select any of those 8 inputs that are on that audio device. So of course I'm just going to probably choose input 1 for all of them, because I'll probably just work in layers rather than recording everything at once. I'll probably record one time, and then I'll go back and record another time, and back and record another time, and I only need to use audio input 1. However, it's going to show me, once I have Ableton connected to this audio interface, it's going to show me in my drop-down list on all of those tracks the 8 inputs that are on that interface. Then for my output device, I'm also going to select the audio interface, because it has outputs that then go to the speakers. So now what's happening is we're setting up Ableton to record, play back, and send audio out to our speakers. So let's say let's say I'm a singer of a band or whatever, and I'm in the studio recording my vocals, and I have my headphones on, and I have the microphone. And now that microphone is plugged into the audio interface, It's getting converted from analog to digital, it's going into Ableton Live, it's getting recorded, and it's sending the audio back out through that same USB cable where the audio is going in, and it's sending it out to the speakers and out to my headphones. So there's a lot happening at one time with that signal, that same signal. I'm going to hear it back simultaneously as I'm speaking, yet it's going through the microphone, through the cable, into the preamp, getting converted from analog to digital, going into the computer as a digital signal, getting recorded and played back in Ableton Live, going out of Ableton Live, back out through that cable, into the audio interface, and then out to the speakers. And that's happening all at once. So, and this is why buffer rate is important, because if we have a higher buffer rate, then our computer is going to take longer to process that information and send it back out to the headphones. So there's a lot of steps that happen in this signal. This is why we need to understand signal flow as engineers, is because let's say I go into the studio and I think I have everything connected and plugged in right, and I have my phantom power on, but I'm not getting any signal. Then I have the ability to track down where that signal is being interrupted. Is it here at this connection? Is it at the connection of the audio interface where the mic cable plugs into the interface? Is it the cable that goes from the interface to the computer? Do I for sure have my input and output device selected in Ableton Live as the audio interface? Are my speakers connected and are they turned on? So there's a lot of places, and there are actually even more things we're going to get into when we get into the studio about this signal flow, because there are other pieces of equipment that we have in this signal flow. So it can get really it's a map. You have to be able to think about this map of where your audio is flowing and where it needs to be flowing and where it's being disrupted in that flow if you're having issues. So this is why signal flow is very important when you're working with audio, because you need to know where it's coming from, where it's going, where it needs to be outputted to. So there's a lot to it. So we're going to go into the studio. We're going to learn a little bit more about it. So the main idea here is to understand all of the points where audio could be interrupted, where that signal could be interrupted. And at the studio, we even have what's called a patch bay. So the patch bay is to get an audio cable from one room into another room. So there's a patch. There's literally a unit where you plug the cable into one side of the wall, and it's connected to the other side of the wall where you plug another cable in, so that you don't have holes in the wall and basically defeat the purpose of having a soundproof space. So the way it works at the university is you have your microphone, you plug your XLR cable in, the XLR cable then goes into the patch bay that's in the live room where the performers are. So we call this the live room where the performer is. So that cable goes into the patch bay in the live room. They're all labeled as in relationship to the inputs on the back of the audio interface on the other side in the control room where the engineer sits. And so they're all labeled 1, 2, 3, 4, 5, 6, 7, 8. So we'll plug our microphone cable into the patch bay in input 1. And then on the other side of the wall, that input 1 is going into input 1 from the patch bay into the back of the audio interface. And then we'll turn the phantom power on to send signal to that channel, and then we should be able to link everything inside of the computer from there and choose where we're routing things. So it's kind of a lot to it, and I would like to give this tutorial to you live, but I just think it's a little bit safer right now that we do it this way. So I hope this makes sense, and let me know if you have any questions.